So we're talking about translations and dilations. Translations meaning shift, right, left, up, down, okay? And dilations mean stretch it and compress it. So the difference between what you remember from Algebra 2, hopefully, is that these will be done without knowing what the true shape is. So this is not based on an f of x squared or an f of x equals x to the third or absolute value of x where you already know the parent function and you're just moving it around. These shapes are not your typical shapes. So the translations is how we'll start, if my TV will cooperate. And there are 3 types of translations. There's your vertical shift, your horizontal shift, and your reflection. And we vertically stretch or shift something by adding something after the function. These are your vertical shifts. Again, it happens if you add or subtract something after the function. So if that was x squared, it'd be x squared, and then the plus whatever would come after. Or if it was x squared, it'd be minus after. What happens in the AP content is it's not an x squared, it is an f of x. F of x just represents whatever the parent function is. So the plus, the number means we're going to shift our function up. The minus, the number means we're going to shift it down. Then comes your horizontal shift, and your horizontal shift happens inside the parentheses. So everything that affects your x coordinate happens inside the parentheses. So if I add or subtract a number, I'm going to move this right or left. And your brain thinks positive means right, but it is the opposite. If it is positive, we move it left. If it is negative, we move it right. So I said it, but I'll also write it up here. If it's positive, we move it up. If it's negative, we move it down on the adding or subtracting after. And then there's 2 types of reflections. There is a reflection over the x-axis, and there is reflection over the y-axis. If the negative is on the front of your function, so it's on the very front of the f of x, or if it's on the front of whatever value is there, then it's going to flip it over the x-axis, which means it takes it and literally flips it upside down. All of the y terms change in that case. The y values, okay? So this is your y values because it would flip it upside down. If it was a negative there, then you would literally take all the y coordinates and you would change their signs. If it was a graph, you would literally take all those y coordinates and flip them over the x-axis. If it's on the inside, remember anything that's on the inside affects your x coordinates. So anything that's on the inside, you would take and switch the signs on your x coordinates, or you would flip it over your y-axis. So this one goes to your x values. So you're flipping it over the y-axis, but the way you do that is by changing your x values. So you're going to see this a couple different ways. One is here's the picture, change your picture of your graph. One is here's your equation, change the equation of your graph. One is here's the coordinate points, change the coordinate points of your graph. And one is we're going to talk about domain and range. How does this affect your domain and range? So it's important to, as we go through this, you understand what affects the x and what affects the y. So this first one says we're going to change it graphically. So given the graph of f, let g of x equal negative f of x. You're going to graph g of x. So when the negative is on the front, what happens? Flips it over which one? The x-axis or the y-axis? So this flips this over the y-axis, which means all x values change sign. So my x and y here is negative 4, 3. I'm going to change it so that it's positive 4, 3. So I flip it over the y. My x, y here is negative 2, 0. I'm going to move it to 2, 0. There's already a point there, but that's my new point. And then I've got a point here, 0, 2. If I flipped it, it'd still be 0, 2. And my last point that was here would go here. The difference is that this is my straight curve and this is the curve back. So that's what it would look like if I flipped it over the y-axis. Okay, now B says let h of x equal f minus 5, graph h of x. So f x minus 5 inside the parentheses causes what kind of translation? To the right 5. So we're affecting, again, right, left would be your x values, right? So every single x value is shifting to the right 5. Or I can literally take this coordinate point, go 1, 2, 3, 4, 5, that's there. This coordinate point, 1, 2, 3, 4, 5, that's there. This coordinate point, 1, 2, 3, 4, 5, that's here. And what color haven't I done? And this coordinate point, 1, 2, 3, 4, 5, it's here. So I get this graph. Now in Notability, it's easy to like kind of draw on top of it and circle it and shift it, but obviously you're not going to be tested on Notability. So I would just make sure you know how to redraw it as well. Questions on that one? All right. Now it says, same set of instructions, but A says f of x minus 4. What's that going to do? Down 4. So remember the verticals stay the same. So again, vertical was going to affect our y values. We're going to take our graph. We're literally going to shift it down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And B says f of x plus 1 inside the parentheses plus 4. So what's the plus 1 inside the parentheses doing? Left 1. And what's the plus 4 doing? Up 4. So you can take each point. You could do, the order here doesn't matter. I can either go up and then left or left and then up. But I'm going to take each point. I'm going to go left 1 and up 1, 2, 3, 4. I'm going to come here. Left 1, up 1, 2, 3, 4. I'm going to come here, left 1, 1, 2, 3, left 1, 1, 2, 3, 4. I'm going to come here, left 1, 1, 2, 3, 4. Here, left 1, 2, 3, 4. Here, 1, 1, 2, 3, 4. So you won't always have that many points as long as you take that overall shape and you shift it the way it should be. You should be good. Questions on that one? Okay, now let's talk about algebraically how we would change these. All right, so these to me like kind of just make sense if you're just messing around with any kind of equation. Wherever the f of x is, if that's unchanged, then you're literally going to replace that with your polynomial. If the x or has a plus or minus inside the parentheses or a sign change, if it happens inside the parentheses, then we're actually taking what's inside the parentheses and we're plugging it into the f of x. But this actually says just take my f of x, and my f of x is x squared minus 2x plus 4, and subtract 1 from it. So I end up with x squared minus 2x plus 3. So we're physically changing our equation algebraically. If you go to B says take my f of x, and instead of making it x, make it x plus 3. So I literally take the x plus 3 and I plug it in everywhere there's an x. So I get x plus 3 squared minus 2 times x plus 3 plus 4. Yep, you got to expand, FOIL, distribute, do whatever you get so that you get rid of anything that can be done. So if I expand the x plus 3 squared, I get x squared plus 6x plus 9. Distribute the negative 2 minus 2x minus 6 plus 4. Combine your like terms, x squared. There's 2x terms, so plus 4x. And there's 3 constants, so positive 9 minus 6 is 3 plus 4 is 7. And these are g of x now. They're no longer f of x. This one was h of x. That one's g of x. Questions on those? All right, now we're talking about using the chart. So we did the graph. We did the equations. We're going to do numerically using our chart. We've got one more to go, which is domain and range. This one says, given the table of values for f, find the following. A says let g of x equals f of x minus 3 and find f of negative 3. So I'm basically finding f of negative 3. I would take that and plug it in, and then I'm going to subtract 3 from the answer that I get. So if I ask for f of negative 3, I'm going to go to where x is negative 3, which is here. The f of x there is 8. So f of negative 3 is 8, and 8 minus 3 is 5. So in that case, I didn't alter my f of x. I found out what the f of x was, and then I subtracted 3 from it. For B, it says find f of x plus 5, then subtract 1 from it. But this time I'm affecting before I even touch my chart. So I'm going to take the negative 3, I'm going to plug it in here, and I'd get f of negative 3 plus 5, and then from that I want to subtract 1, which means I'm getting f of 2. So I go to where my x is 2, which is here. My f of x is 15, so this is 15 minus 1, or 14. Now, if you were to get your f of 2, and that was a number that was not in your x column, obviously you did something wrong, so that should be a catch. But also, they will put those values over here on the right-hand side to throw you off, so be really careful. They'll purposely give you that distractor. Good so far? All right, now let's talk about domain and range. So what is domain representative of, your x or your y values? Your x values. So think about the things that affect your x values. It's all the things that happen inside the parentheses, right? If I put a negative inside my parentheses on the x, it's going to change my x values. If I put a plus or minus inside the parentheses, it's going to change my x values. Everything that happens outside the parentheses affects my y values, which y values would be your range, right? So if I put a negative on the front, it's changing my y values, which means it's changing my range. If I put a plus or minus outside the parentheses, it's shifting it up or down, which is affecting my y values, which is affecting my range. Does that make sense? So if I look here, the minus 2 is affecting what? Domain or range? Domain, because that's changing my x values. Does that make sense? Yes. This inside is your x, which means your domain. And what that minus 2 is doing to the x values is what? 2 to the right. So if I looked at my domain, which was negative 2, 4, and I shift everything to the right 2, I'm basically adding 2 to each of these. So it'd be plus 2 and plus 2. And I end up with 0, 6. That's my new updated domain based on the x minus 2. Now, what is the plus 3 affecting outside the parentheses? This is going up or down, which is changing what, x or y? Y, which means range. And the plus 3 does what to it? You said it, up 3, right? Up 3, which means I'm going to take all of my y values and I'm going to add 3 to it. So negative 3, 7. And I add 3. I'm shifting everything up 3. 0, 10. And there's my updated range. Bring hit a question? Okay. So the first thing you have to figure out is how does this affect my graph? Does it affect my x values? Because then that's my domain. Does it affect my y values? Because that's my range. So again, anything inside the parentheses, domain. Anything outside the parentheses, range. These are for your grid transformation, so we haven't stretched or compressed yet. These are just shifting right, left, up, down, reflecting. All right, now let's talk dilation. These are going to stretch or compress your graph. In Algebra 2, sometimes we say stretch or shrink. Shrink is now compress, okay? And in Algebra 2, we would say it makes it narrow or wide, those kinds of things. Now we have to give by what factor, so we have to get really specific. So if it's a vertical stretch or compression, then it happens by multiplying something on the front of your f of x. So it happens on the front, outside the parentheses again, because this is a vertical stretch, which means it changes your y, which changes your range. If that value is bigger than 1, then it's going to make it stretch vertically. It's as if I take my graph and I pull it from top to bottom, right? That would stretch it vertically. If that value is less than 1, and we're ignoring the sign because the sign's the reflection. So if that value is less than 1, then it's like the ceiling and the floor caving in on your function. It's going to squish it vertically, which we call compress, okay? So it's still on the front. It's still both of those happen on the front. This would look like a 2 f of x, and this could look like a half f of x. That's what the difference would be. The 2 is a vertical stretch. The 1/2 is a vertical compression. They will also just say dilation, vertical dilation, and it encompasses both. But it's going to ask you by what factor, and it is a factor of A. So it's factor of A. So if I ask you what's the vertical compression or stretch here on 2 f of x, you would say it's a vertical stretch by a factor of 2. On 1/2 f of x, you would say it's a vertical compression by a factor of 1/2. Now, where it gets weird is and for those, you would change your y values. You would literally take all your y values and you multiply them by whatever that factor is. So if it was 2 f of x, I would take my y values and I'd double them. If it was range, I'd double it. Same thing. Now, when it's horizontal stretch or compression, the language changes. It looks very similar, but the language changes. If the value is being multiplied inside the parentheses, now it causes a change to your x, which means it's like the walls caving in or the walls pulling out. So we're going left to right. If the value is bigger than 1, it's called a horizontal compression. The walls are caving in. The bigger the number, the more they cave in. It still makes it narrow if you think about your graph, but we use a different word to describe it. That's a horizontal compression. And if it's less than 1, again, we ignore the sign, so it's less than 1. Now it's a vertical stretch, a horizontal stretch, like the walls are pulling out left to right, okay? So if it's inside, horizontal stretch compression. If it's on the front, vertical stretch or compression. The other difference with horizontal is that the change is by a factor of 1 over b. So now if I had f of 2x and my stretches or shrink is happening inside the parentheses, this is a horizontal compression by a factor of 1/2. So if it's on the front, we leave it alone. If it's inside the parentheses, it's the reciprocal. If you think about it, if you're doing your vertical stretch, your vertical shift up or down, or your horizontal shift left or right, the inside's the opposite, right? If I add or subtract inside the parentheses, we go the other way. If it's outside, you go the natural way. It's the same for compression. Compression and stretch, if it's outside, you keep it the factor the same. If it's inside, it's the reciprocal. All right, so this one says, we're going to go through all the same things, but now with stretch and shrink. Graphically, let g of x equal 2 f of x minus 4. So the 2 on the front causes what? Vertical stretch by a factor of? Good. And then the minus 4 on the outside shifts down 4. Both of these things would affect our y values or our range. Now here's the catch. You have to you have to stretch before you move. Stretch before you move. So picture it to be like in the morning when you wake up in the bed, before you get out of bed, you want to stretch, get your body moving, and then get up out of the bed. So stretch before you move. Sometimes it doesn't matter, but sometimes it does and you won't know when it's happening. Yep. It depends a lot with the reflection. Yeah. All right, so I'm going to first stretch it. So all these values of my y values, I'm going to take and double. I'm going to multiply them by 2. So my 3 becomes 6. My 0 would stay as 0. My 2 becomes 4. My 0 would stay as 0. So just the vertical stretch does that. Then we move. Everything gets shifted down 4 places. So I'd go down 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. And my final translation, oops, is here. So if you think about if you had shifted it down first, your zeros would be at -4, and then when you double it, you'd be at -8. Or no, yeah, so it changes it. Yep.
So you doubled the y values of the
Yep.
And so when the number's inside, you double it.
You actually do by 1 over what's there. So that's next.
But it's to the x value?
But it's the x values. Yep. Questions on that one before I erase it? Okay, again, if you want to duplicate it so you have 2 graphs, that's fine because we're going to write all over the next one. All right, B says let h of x be f of 1/2 x minus 3. So you don't want to distribute this. You want to keep them separate because that's where it's easier to figure out your shifts. If it was distributed, you'd have to take it out. The 1/2 inside the parentheses is a horizontal dilation. If it's 1/2, it's by if that's 1/2, then it's by a factor of 2.
So you multiply the x by 2.
Yep, by factor of 2. Good? Yeah. Okay, and the -3 inside the parentheses is what? Right 3. So we're going to stretch, then move. I'm going to take my x values and I'm going to multiply them by 2. So this -4 goes to -8. No, it's by the reciprocal. So when it's horizontal, you flip it. Then the -2 would go to -4. The 0 would stay 0. The 2 would go to 4. So the stretch alone looks like that. Then I want to shift it to the right 3. So all those points are going right 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And there's my final B, or h of x. Questions on that one? All right, now we're going to affect our translation of our dilations algebraically, so by our equation. Again, I think this one's not so bad. You literally just like plug it in or don't plug it in. If it looks like this, my f of x stays as f of x, but then I want to multiply it by 3. So I'm going to do 3 times whatever my f of x is. That stays alone. And then I'm going to take that answer and I'm going to subtract 1 from it. So then I would distribute the 3x squared plus 12 minus 1, and I get 3x squared plus 11. All right, then go to B. This time my x changes, so what I plug in is a half x. So I'd get 1/2 x squared plus 4. That's what I would get by plugging in 1/2 x here. And then plus 3 comes after that. So 1/2 squared is a half times a half, or 1/4 x squared plus 7. Yep.
Wouldn't, when you plug in the x squared plus 4, wouldn't you do 1/2 times 4?
No, because you're just doing one. So this time, because it's in here, we plug it in. So you're plugging it in the place here. Does that make sense? If the half's on the front, then it gets distributed to both. But if it's inside the parentheses, it's what you plug into the x. All right, again, we did points, we did algebraically. What's left is domain and range. So given the graph for f has a domain of -2, 4, these are both in parentheses, so those don't change. The parentheses brackets won't change, so be really careful, okay? And range is -1 to 5 with brackets. Let g of x equal 3 times x minus 1 minus 2. What order do you do it? Stretch or move? Stretch, so we're going to do the same thing here, okay? So a 3 on the front causes what kind of dilation? Vertical by a factor of? By factor of 3, okay? Then the -1 inside, right to the 1, right? 1, which means I take my x and I add 1 to it. So the vert means that I'm going to do 3 times y. And then the -2 at the end, down 2, which means I'm going to take all my y values and I'm going to subtract 2 from them. But that has to happen after the stretch. So which of these affect your range? The 3y and the -2. Which of these affect your domain? The right one, right? So this changes my domain. God bless you. And these both change my range. So I'm going to take my range, my -1, 5. I'm going to multiply by a factor of 3. I get -315. And then I'm going to shift it down 2, so I subtract 2. -5, 13. This is my new range. Then my right one affects my domain. So I take my domain, my -2, 4, and I want to go to the right one, so I add 1 to each of these, and I get -1, 5. Questions? So first, you got to figure out what they are, and then what they affect. X or Y, vertical or horizontal, domain or range. And remember, we stretch before we move. Greenlee.